Wednesday review, and then Thursday, Friday test. It's a 2-day test. It's a long test. Okay? Miss Hanson's like, okay, anyway. Miss Hanson is 1-day test is 2 days too many, you know. Even a 1-day test is 2 days too many. It should be a negative 1-day test. Anyway. That's the joke. Anyway, guys, but everybody, shh. Here are my expectations for the slackers amongst you. Everybody pay attention. Come Monday, come hell or high water, all your missing work should be done. So if you're missing 1 assignment here or 2 assignments here, by Monday everything should be turned in. I'm just giving you advance notice. Failure to do so will unleash the beast inside me. Okay, I'm serious. You have not seen that side of me. We're learning the last concept. So I'm happy some of you who are here instead of being in the AV Bio trip is because we're formally, like I think Ms. Himpelman or Katina asked, are we learning something new? And I said, it's all new today. This is brand new. This is brand new. It's too much? No, it's not complicated. It's not complicated. The other class was saying, man, this is the easiest stuff. I get it. Okay, don't write. I have to give some notes first. Shh. So, please write this down. Shh. It's called the maximum error bound theorem for alternating series. It's called the maximum error bound as in boundaries, the interval for alternating series. So let's write an alternating series. So let the alternating series be negative 1 to the power of n, an. I'm going to open it up, say first term, second term, third term, negative 1 to the power of an. The next term will be negative 1 to the power of n plus 1, an plus 1. The next term will be negative 1 to n plus 2, an plus 2, and then goes on to infinity. Okay? So that's an infinite alternating series. Okay, so suppose we use the first n terms to estimate the sum. Can you see there's an infinite sum? It is not a geoseries. It could be any alternating series. It could be any alternating series. But suppose we just use the first n terms. Don't get alarmed. I don't mean literally n. It could be the first 3 terms. Is that clear? First 4 terms. And can be any number, any finite quantity. To estimate, let's call this guy f of x. That's a function. We'll have an x in it. To estimate f of x. So I hope you wrote this in one line. I'm running out of room, so I'm writing like this. It would be cute on your notebooks. You're also writing like that. I am running out of room. Okay. Now look at the board, please. If you have copied this, put your pencils down so I can explain what's going on. Like, where are we going with this? We are using the first n terms to estimate that. Is that clear? That's what we are using. The first 5 terms, the first 10 terms. So now look at the board. Isn't the actual series infinite terms? And if we are using only the first n terms, are we basically ignoring these terms? I'm going to use a concept, think about it and say, oh yeah, that's obviously true. So isn't that the actual value? Is that estimate? So will there obviously be an error? Is it a remainder or an error? So label that, please. Again, I've written in an awkward fashion. So that is called the error. Some books also call it the remainder. So this theorem says, for an alternating series, the error, so those of you in stats last year, some of you are like, I'm going to, now remember you did something called the least squares regression line? Yeah. Now remember that, okay, just play it on. Even if you don't remember, you'll come back. I'm a good stats teacher, I'll tell you. So assume for a second we're estimating the y value using the LSRL, the least square regression line. Isn't the line giving you the actual value? Like the actual value? If I were to plug it into the line, will I give the estimate? Is the difference basically the error? Who, if anybody, recalls the technical term in statistics for error? Hint. It starts with the letter R, not remainder, some other word. Residual. How many of you vaguely remember that? The residual. Okay. The residual formula was actual minus the estimate, the predicted value. We'll use the same concept. So the error is nothing but, so we want the absolute value of the error. Okay, so write down, we want the absolute value of the error. Like in the worst case, what is it? So absolute value of the actual value is f of x minus the predicted. Now, look at the board. Are we using the first n terms only? So that is my estimate. The difference will give you the error. Again, this is infinite terms. If you want to make notes, that's all infinite terms. You're using all terms. That's f of x, the actual function. Here, we are using only n terms. That's the error. Or the remainder. We're actually ignoring all those terms. Okay, so the theorem says that this error is at most, so less or equal to, the first skip term or the n plus 1th term. Okay, that's what the theorem says. So the error in estimating will always be less than the first missing term, the n plus 1th term. Okay, that's what the theorem says. It works for only, relax, when you do problems, say, okay, that is stupidly easy. It works only for alternating series, alright? It must be an alternating series. Relax, all the questions you get in the AP exam related to this question are alternating series. Let's do a couple of problems, you get a feel for what's going on. Okay, can you please copy down 1? Now we're coming to problems. Okay, I'll show you the application of the theorem. Like, oh, I see what's going on. So 1a says, write the first 3 terms and the nth term of the power series for e to the power of negative 1/2. And I'm happy Ms. Rios is here. Oh, so if you're doing e negative 1/2, which series should we be focused on?
Yes.
Ex, so let's write the ex series, which is plus over 2 factorial plus x cubed over 3 factorial plus dot 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 x to the power of n over n factorial dot dot dot. Now we want e to the power of negative 1/2. So I should replace every x with negative 1/2. So e to the power of negative 1/2 is 1 minus 1/2. I'm gonna, okay, if you're willing to skip steps and do stuff mentally, is that negative 1/2 square? Will that become positive 1/4 over 2 factorial? What's negative 1/2 cubed going to be? Negative 1/8 over 3 factorial plus dot dot dot, and the n term will become. I'm going to rewrite it. See if you're comfortable doing it. I've been training you. We've been doing this every day. The AP will usually have it as negative 1 to the power of n, and then can you write this as 2 to the power of n factorial? See if you can grasp the algebra. That's 2 to the power n in the denominator and factorial in the denominator. Just remove that. So Ms. Basu, when you write the n term, observe, adjust numerator denominators. Alright. Is everybody okay there? So read the question. Just say the first part was stupidly simple. It carried 2 points. Just write the first 3 terms. And now I know what some of you are thinking. Look at the question again. Did it not only ask for the first 3 terms? Yes? I know, yes. We've written a 4th term. Not necessary, but there's a concept I want to talk to you about. Now read B, please. Read B. Write it down if you need to. Oh, Miss Nguyen is not here to supply the notes. But Katina's already sent her notes, so we're good. Okay, write on B, please. It says, suppose the first 3 terms were used to estimate negative 1/2. Please understand the series is an infinite series. But we're using only the first 3 terms. The question then says, what would the size of the error in the estimate be? Okay. How much would that error be? So look at the board. So I'm going to apply the theorem. So understand what's going on. Are we using basically the first three terms to make the estimate? As in, I take a calculator and just add these up. Okay, that's what I'm talking about. I take a calculator and add these up. That'll give you the estimated value. Now, look at the board, please. Is the error basically all of these till infinity? No, but the theorem says, no, the error, so I'm showing you notation. So the error, we're doing part B. So the notation in a textbook or the AP exam for error is this. Absolute value, we're using absolute value, or comma. Is the actual value basically, we didn't call it f of x, so let's label it. F of x is ex, correct? So observe my notation. F of negative 1/2, is that basically infinite terms? Yes? Look at part B. How many terms did we use? Now observe the notation. This is the actual value minus the estimated value, using only 3 terms. Again, get comfortable with that notation. Actual value minus the estimated value using 3 terms. Now, according to the theorem is stupidly simple. Look back to your notes or what the theorem said. Will it be less or equal to the n plus 1 term? Look at me. What is n? How many terms did we use? So which term should I focus on? The 4th term. There's a reason why I wrote the 4th term. So it will be less than that guy. So write down less or equal to. By the way, look at me. Are we using absolute values? So should I write that? Well, absolute value can be a negative number. So 1 over 8. Can I write 1 over 8 times 3 factorial, basically? Okay, everybody, take out your scientific calculator, not scientific, I mean your Inspire calculator. Let me show you where the factorial key is. You need to know where it is. Okay, turn your calculators on. Okay, yeah, just grab one. But guys, if you're borrowing a calculator, make sure you replace it, unless it is yours. Okay, now common sense dictates, look at me, is 3 factorial 6, 6 times 8 is 48. But I want to give practice on where the factorial key is. So type 1 over 8 times in the denominator. Make sure you're in the denominator. Times. Okay, here's where the factorial key is. Look at the letter on the bottom right. I'll speak slowly. Bottom right, look for the letter G. Don't hit G. Look at the number, look at the character next to it. Hit that, you should see the exclamation mark symbol. Okay, point, how much? 0.048, what? No, 0.02, what? How much? It just says 1 over 48. It does not give you a decimal.
You do the decimal first, so 1.0.
If you hit control enter. Okay, hit control enter, apparently it gives it then. Okay. Anyway, how much was it? 0.0? 0208. Now, put your pencils down so we can talk about what we just found. Look at the board. Now, okay, guys, look at the board, please. Remember, this is the actual value. Okay? Sorry, I take that back. This till infinity is the actual value. We have an estimate. The error in our prediction will be at most. The error is only going to be that, 0.02. I'll be off by about 0.02. That's not terrible at all. Understand what's going on. Even if I take infinite terms, at worst I'll be 0.02 off. Does everybody understand the significance of what we found? The theorem tells you at worst the error will be this. Okay, that's what we found. Okay, now look at part C, please. Copy it on part C. Part C says, based on your result in part B, actually estimate that sum when using the sum of the first 3 terms. So what would our actual sum be? Okay, estimate that when you're using 3 terms. So the question is, so what's a good estimate for the sum of those infinite terms? So let me show you how to do this. Look at the board, please. Is that basically the sum of infinite terms? So the question says, can you give me a bound? So the sum should lie between what 2 values? What's a good guess? Ooh, is that basically the sum of 3 terms? Can we not actually calculate that easily? Is that basically this guy? So why don't we do that by hand very quickly? So make a note. So I'm going to calculate. So we're doing part C. First, I'll calculate this by hand very quickly. So grab your calculators. Type 1 minus 1 over 2. Repeat, 1 minus 1 over 2 plus. Is that basically 1 over 8? So type plus 1 over 8. Repeat, I'm just adding these 3 terms up to figure out what that value is. Tell me what your answer is. 0.625. Is everybody okay there? So the question says, well, what's a good estimate of that sum now, of the actual sum? So look at the board. I did not do this in the other class, but I'm going to switch my notation. You'll say, oh, this is much easier. We'll call this guy S for the actual sum. Okay. In the other class, we just use f of negative half. So basically, S minus 0.625 is less or equal to 0.0208, correct? 0.0208, correct? Can I write this inequality that we do for convergence all the time? Look at me. So is not S minus 0.625 greater than negative 0.0208? Less than positive 0.0208? The simple absolute value inequality we write. And last step, what do? I'm solving for S. Add 0.625. So this will become 0.625 minus 0.0208. 0.0208 plus 0.625, or technically 0.625 plus, because that's the bigger number, right? Okay, I want this half of the class to calculate this guy, this half of the class calculate the right guy, so we can accelerate. .6 louder. 0.4, and that guy was 0.6458. Again, it is okay to write that's basically f of what is it? Negative 1/2 was it? Okay, put your pencils down so you can understand what we just found. So what we are really saying is the sum of infinite terms lies between these two numbers. That's an outstanding estimate. The sum of those infinite terms, e negative 1/2, lies between 0.6042 and 0.6458. Because we found the error, we found the actual value, we did the algebra, and we found out bounds. Now, I'm just curious. Use your calculator, hit e to the power negative 1/2. We did not do this in the other class, but I'm just curious. What's the actual value of e to the power negative 1/2? Because your calculator is going to give you infinite terms. What did you get? 0.6? 0.60? Louder? 606531? Okay. So it lies between those two values. Not a terrible estimate. Oh! Here's the magic! And we only use 3 terms. Please understand that. Now I'm going to say a couple of profound ideas. Think about it and say, oh yeah, that's obvious. Is it obvious the more terms I use, the error will fall? Is that kind of obvious? Will this get narrow and narrow? Is that kind of obvious also? Okay, our estimate will get closer and closer to that number. Okay, let me give you 30 seconds. Look over all the steps we did. Say, okay, what's going on with this concept now again? So our goal is to estimate infinite terms. So in statistics language, that's the parameter of interest. But we are using a statistic. We're using an estimate. We're just using,
So
the actual sum of E lies between that and that. Those are the bounds. Yeah, that's your answer. Yeah. So it says based on B, estimate when using the sum. So what's our estimate for us? We have an interval. Since I want Marcus to be happy, on the homework I'll clearly say provide an interval for the sum. Okay. And then part B said, well, estimate the error. So our formula was the first skip term is basically the upper bound for the error. And part C said then, okay, you know the error, and we can actually find the sum of 3 terms, then the sum should lie between what 2 values? We solved that inequality and we found the value. Okay, now have a look at part D, please. Now remember, our error was 0.0208, and I finished saying, I'm speaking so look at the board, and I said if you use more terms, will the error keep falling? That's what part D is checking for understanding. It says how many terms should be selected for the size of the error to be less than that? So can you please write that down? I want you to relax. We'll do kind of guess and check. I don't have a quick answer. We're just going to guess and check like how many terms should we take. If we take 3 terms, the error is 0.020. Okay, now look at the board, please. Look at the board. Remember, I'm speaking, so look at the board. Remember, we use 3 terms. So the error, we looked at the 4th term. Yes. Obviously, that is much smaller than that error. Should we look at more other terms? So assume for a second we plug it in. Now remember, this is the nth term. Okay, that's the general formula for the nth term. So I'm going to focus on the nth term for part D. I'm going to plug in n to be different values and see what term we should be focused on. So observe, this is the first skip term. This is the n plus 1 term. And this is the error. So I'm just going to do guess and check. I don't have a shortcut formula. Assume for a second we plug in, which value n did we plug in? 3 or 4? N was 3, right? And we looked at the 4th term. So why don't we plug in n equals 4, n equals 5, n equals 6. So negative 1/2 to the power of 4 over 4 factorial. Negative 1/2 to the power of 5 over 5 factorial. I'm just calculating the different errors. Negative 1/2 to the power of 6. It's one of the first few numbers over 6 factorial. Please understand, I'm using the nth term. Now, look at the board so you understand what's going on. Do you observe? That's the general pattern. Remember, I did not write the other one. Look at me. Can you see I wrote this? Will the next term obviously be x4 over 4 factorial? Do you understand? Isn't that what's going on here? Okay. I'm just using the n term to plug in. Okay, now I'm going to divide the class into parts. So you guys calculate that value. You guys calculate that error. You guys will calculate that error. We'll see which one is less than 0.000. Type it in the way you see it. Okay, if you have any of them, just call out which one you're calling out. Okay, you are the second guy.
Yeah.
So all of you, I hope you're making this chart. Okay, if you have n equals 5, tell me 0.0, how many zeros?
3,
3 zeros? Continue.
2, 6.
2, 6. Okay, if this guy is 0.0026, we don't care about this number, do we? I hope you understand the logic. She already calculated that. For those of you who don't get it, am I not supposed to be lower than 0.0?
So 5.
Wait, so I'm writing next to 5. I'm writing next to 5. So this guy. So I cross with the 4 guy. Will the 4 error obviously be bigger than that guy? Now, those of you who have 6 guys, what is the 6 value?
0, 0, 0, 0, 2, 2.
Okay. Now, put your pencils down so we can talk about what's going on here. So the question is, well, how many terms do we take? So I'm looking at the first skip term. So the n plus first term, the next term I should look at is the error. She already told me the 5th guy. Have a look. Isn't this number actually bigger than that number? So that doesn't work. Is this guy smaller than that number? Now watch carefully. So I want to see Mashari answer this question like that. So how many terms should I take then? No. This is the error term. N equals 6 is the error term. So how many terms should you have added up? 5. Does everybody understand that? This is the first skip term. This is the n plus 1 term here. It's there. And that was 6. So should the actual term have been, we should have added up. So please write this down. So it says how many terms? So we should take 5 terms for the error, or rather absolute value of the error, to be less than or equal to 0.000. Please understand, in the formula is the skip term. Yes, Mr. Sakerson.
I think I missed it earlier, but do you not care about the sign of the n plus 1 terms?
Good question. We are talking of absolute value of the error. So I did write the word absolute value somewhere along. He says, what if the error is negative? No, we're talking of the absolute value of the error. Okay, we have actually skipped a problem over there. Look at part B. It said explain. Can you see that word explain? We didn't even answer that question. I was saying, man, where's that explanation step? So go back to part B, please. Go back to part B. Okay, the one that said what is the size of the error. Okay, explain. So look at me. Feel free to go back to your notes. Is this formula applicable anytime or it's only for certain series? Say it loudly, Ms. Yunus. Alternating series. So we need to check for the alternating series conditions. Alright, so basically we are applying AST. So go back over there when you and just write on since. Okay. Summation -1 to the power of n an is alternating. Okay, remember the E series. Guys, look at your E series. Is that obviously an alternating series? No, don't take my word for it. Is that an alternating series? Yeah. So we're basically checking the conditions of the alternating series. Is an alternating series. What are the conditions for the AST? Thank you. The nth term, limit, n approaching infinity. An should be 0. Look at the board so you understand. Yes, it is approaching 0. What is a small number? Look at me. That's 1/2 to the power of infinity. Can you see n is approaching infinity? Will that collapse to 0 quickly? And then what is the second condition? Thank you. An is decreasing. Okay, look at the board so you understand why it is decreasing. Are we dividing by larger and larger factorials? Is that number going to fall? Yeah. So that's your explanation. So make a note to yourself. That's the explanation you're supposed to write. You're basically checking the conditions for the alternating series test. Before I move on, because some students will have been confused by what happened in part D. So go back to D, please. I want to make sure you understand. So when we are calculating the error, look at me. Remember, we are looking at the first skip term, right? We're looking at the next term. So when we found out 6, that error starts getting less than that. So we must have added 5 terms. So we found the error from the 6th term. Does everybody understand that? That's why we said we should have added 5 terms. Because we were plugging into the skip term. And we said, okay, if n is 6, so on. Let's do a few more examples. Now it's very easy. Repetitive. Copy down to A, please. It's gotten hot here. I hope you can appreciate my kind of Costco shirt, $19.99. No, it was $15.99. It was 2 for $29.99.
Are there clothes on Wish.com?
Sorry? I believe there are. Yeah, jackets. I don't think like regular shirts and pants. More like jackets and so on. Okay, we'll do part A. So we can accelerate. So what series should I be focused on? The cos x. Oh, another thing, Ms. Basu. When you write series, the question says, I'm just making this up, ex minus cos x series. Remember you write one above the other? Write it sideways. It's easier because students think, how is she subtracting? So write ex minus e negative x, and you can see. Okay? Do me a favor, please. So we'll write f of x, left hand side. Oh, no, not f of x first. First just cos x, correct? So we're doing evolution. Formula 1 x squared over 2 factorial. See, Ben Suvia kids calling out? Yeah, you need to come prepared. Minus dot dot dot. This is alternating, right? Guys, all are odd powers. So x to the power of, sorry, even powers. X to the power of over 2n factorial. It's even. It's cosine x. Oh, 4 terms. Okay, is that why rhyming is kind of staring at me in bewilderment? Plus dot dot. All right. I should replace every x with. Oh, so the second term really becomes over 2 factorial, and the third term really becomes over 4 factorial. Next term becomes 6 factorial plus dot dot dot. Now careful. I'm replacing x with radical x to the power of 2n. And it just becomes, I love you, John, x to the power of n over 2 power n factorial. I hope you understand your algebra. X radical square will become regular x. And then I multiply every term by 4x. Okay, now I'm ready to write f of x equals 4x cos radical x. If you're writing good notes, can you please draw a skull? Dom, why don't you do double duty, which is send the notes to the class. You're the win today. Okay, you're the win of today. So write neatly. Like the Viet kid. No, Dom. You're writing like the Viet kid. Yeah. Okay, stay with me please. So f of x equals, okay, I'm going to multiply every term by 4x. So the first term is minus over 2 factorial plus 4x cubed over 4 factorial. Remember guys, I'm just multiplying every term by 4x. Mr. Masharia was confused. He thought we were replacing x with 4x. No. We're just multiplying by 4x. Minus 4x4 over 6 factorial plus dot 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 negative 4 to the power, negative 1 to the power n. Now watch, this looks a little weird. Will it just be 4 there? But I'm multiplying by x. So x to the power of, what the hell?
Wait. Equals 1.
Over 2n factorial. Okay? Okay, now read part B. Part B says, I'll give you time to write it, but I'm just reading with you as you copy it down. Part B says, suppose we wish to estimate the power series in A at x equals 0.1. So x is given to be 0.1 using the first 4 terms. So we're using 4 terms to make an estimate. By how much would our estimate differ from the actual value? What are they really asking for? Error, thank you. Okay, those of you who are writing good notes or your last name rhymes with song, if you will underline that phrase, because some kids will befuddle, like, what are they asking for? By how much would our estimate differ from the actual value? In simple language, how much is the error? Ooh, how many terms are we using? So which term should we focus on? The 5th term? So let's have a look. That's 1, 2, 3, 4. Can we make a guess about the 5th term? First, let's use notation. So write down maximum error, comma. I'm using notation. So I want to foster good notation. Is that basically f of 0.1? Yeah, f of 0.1 minus, how many terms are we using? f4 of 0.1. It'll be less or equal to. Okay, let's just make a guess. Yes, please. Oh, no, sorry. That was a typo, guys. Again, that was a typo. Thank you. I pointed out in the other class. Sorry, that was a typo. If I was a good teacher during my break, I would have fixed it. If I was a good teacher. Okay. So, guys, make a guess about the pattern. What will the next term be? Hint 2, 4, 6, 4, 4, 4. X1, X2, X3. So, what is my next term? 4, X, 5 over 8 factorial. And according to Psycho-Z, he says, do we care about the signs? Nah, remember, absolute value. We're talking the absolute value of the error. And what is the x value given to be? Can I plug in 0.1? So add x equals 0.1. It's 4 times 0.1 to the power of 5 over 8 factorial. Use your calculator to do this. In the other class, we got 10 to the power of negative 9 or something. Confirm that. It's going to switch to scientific notation. But I want to have a conversation about scientific notation. Again, type it in the way you see it. 4 times 0.1 to the power of 5 divided by 8 factorial. Okay, somebody call out what you get. Just call out what your calculator is saying. 9.9206. Now careful. Guys, I hope everybody is doing it. Look in the corner. It says E negative or 10 negative. E negative 9. It is not. How can the error be 9.9? The error is not 9.9. It's so small, it switched to scientific notation. Let me show you what this means. Everybody over here, by the way, is this number correct? Negative 10? Okay, negative 10. I'm just writing down whatever you call out. Okay, now look at the board, please. Shh. Now, all of you have learned this in either middle school or your physics or chemistry classes. Maybe? Rani is just smiling. Okay, here's how you do scientific notation. This is 9206 times 10 to the power of negative 10. For those of you who have forgotten your scientific notation, all of you, here's how we do scientific notation. You write, guys, leave some space. 9.9206. Is 10 to the power of negative 10 a really small number or a really large number? Small. So the decimal is going to move 10 places to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And fill these in with zeros. In simple language, those of you who want a shortcut, you'll have 9 zeros. Okay. You'll have 9 zeros. So if you have negative 4, you'll have 3 zeros. Okay, put your pencils down so we can talk about what we just discovered. So, for that particular series, look at the board please. For that particular series, if we use only 4 terms, the error is virtually 0. The estimate is so strong. Okay, the theorem tells you it's so strong that if you just use 4 terms, we're looking at the 5th term, the error is virtually 0. Actually, the smartest kids are saying, Rama, I'm willing to bet even with 2 terms the error is virtually 0. Does that make common sense? If that is so small, I could have used maybe x4 or even that. 0.1 square or point that times the 4x. The error will become 0 virtually here. Virtually 0 very, very quickly. Okay. Oh, what is the last word in that question? No, read the question. What is the explain? Can we write the same explanation we did earlier? Write down since. Summation, -1. Oh, sorry, notation. Can you go back there? Can you go back there and write this is summation -1 to the power of n a n? So notation is easier to write later. Since, Ms. Basu, we'll be attentive to the notation, please. Okay? Because you can see, Eunice observes every word you write. So she's going to come back and say, she didn't write summation an, she just wrote summation a. I'll say, yes, Ms. Eunice, it's supposed to be summation an. She didn't write infinity. Isn't it supposed to be infinity? Yes, Ms. Eunice, it's supposed to be infinity. She didn't write 0. Is it going from 0 to infinity? Yes, Ms. Eunice. She didn't write equal to sign. Yes, there's supposed to be an equal to sign. I'm kidding, Eunice. I'm actually gently mocking both of you. Anyway, moving on. No, she pointed out some errors on yesterday's homework and she was right on every count. Okay, anyway. So summation an. You didn't write. I'm kidding, I'm moving on. That's -1 to the power of n. Is an alternating series. Is an alternating series. And limit n approaching infinity, an is obviously observed. We're dividing by 2 n factorial, 0. And are we obviously decreasing in value? And an is decreasing or are decreasing. That's all you have to say. Basically the conditions, relax Marquez, we're just writing the alternating series, guys. Limit n of an is 0 and an is decreasing. What we always write for alternating series. Okay, in the other class, part C got stupid. Is the error word virtually 0? It said Bayes estimate the sum. It's pretty silly. Okay, so we're going to skip part C. Okay, copy on number 3, please. Are you guys stretching? No. You want it? Do you want to stretch? Oh, guys, it's getting a little repetitive. Can you make the 4 terms to 3 terms? Can you make that 3? Again, it's getting repetitive. Make it 3 terms. Repeat, change the problem. Why is this problem, hint, the way it's written, different from the other ones? Why is the series they provided looking different from the other ones? Thank you. Mr. Bunjan says the other ones were expanded, right? Here they're using summation notation. Relax, this is actually easier. So what's this? If we're using 3 terms, I'm speaking, so look at the board. If we're using, Ms. Dawn, can you please remind me to send this document? All right. If we're using 3 terms, which term should we look at to find the error? The 4th term. Now look at me to figure out where the 4th term is. Are we starting with 1? So for the 4th term, we just need to plug in 4. Did everybody understand that? So this actually is easier. We don't need to waste our time expanding. So we're starting at 1. The first skip term is the 4th term, and you can just plug in 4. So make a note in your notebooks, please. The a n plus 1. So write down, so we're using the first 3 terms. So basically n equals 3. So the a n plus 1th term is basically the 4th term. We're starting with summation 1 to infinity. Or technically summation. Therefore, I'm just going to plug in for the 4th term, n equals 4 there. Okay. Understand why we're doing what we're doing. You just plug in 4. Okay, so notation, maximum error. I want to see if you got the hang of the function notation. What am I writing? F of negative 1.9 minus, hint, we are using 3 terms. F3, very good, Ms. John, of 1.9. Will be less or equal to. Then I'm going to start plugging in n equals 4. Do I care about plugging in negative 1 to the power 4? No, we're looking at absolute value. So x plus 2 to the power of 5, very good. Radical of 5, because we're plugging in 4, times 4 factorial. X equals negative 1.9, we're plugging in. Don't forget, they gave you the x value. Can you plug it in? What's negative 1.9 plus 2? 0.1 to the power of 5 over radical 5 times 4 factorial. Can you use your calculator, Dora the Explorer, and tell me what that is? Type it in the way you see it. And then you just realize if you hit control enter, apparently it switches to decimal notation.
1.863.
And E negative
E negative 7.
E negative 7, so it means 6 zeros. 1, 2, 3, 4, 5, 6. Call out the number again.
1.863.
1863. Somebody confirm that? Okay, I'll be honest though. Most of the time, the error that the questions the AP gives you, maybe 2 zeros, 3 zeros. Okay, I'm kind of engaging in overkill. All right, I'm just letting you know. He's like, hold a second, all of these have the error virtually 0. That's because of the functions I've chosen. Exactly. Yeah. Okay, last problem dealing with error. We have 2 more. Copy that problem down, please. Guys, I'm going to accelerate. We're kind of 5 to 7 minutes behind the other class. But of course, what's new? Okay, copy that down very quickly. Damn it! Should we write first 5? Can you see clear indication of cut and paste? Copy and paste. So first 4 terms, all of them just say first 4 terms. So just copy the question, paste it somewhere else. Make it first 5 terms, alright? Repeat. Make the instructions first 5 terms. And the question says, by how much would f of negative 1/2, which is the actual value, differ at most from our estimate? Hint, we're using the first 5 terms. So the question is just asking for the maximum error. Okay, nobody speaks. I want to see if you're attentive. Okay, so we're using n equals 5 terms. So we will look at the 6th term. So basically for the error, look at the 6th term. Nobody speaks. Look at that series. Why is that series different from the one we just did, Mr. Psychosi?
The bottom bound is 0.
The lower bound is 0. So for those of you who don't understand the significance of that, in the earlier problem, was it easy? We started at 1, so the 1 is the first term. So I'm going to help some of you say, I don't know what's going on. So if n equals 0 is the first term, and I want the 6th term, what should I really plug in? 5. I hope you understand that. So plug in 5. I hope you understand why. We're shifted by 1. Now it's stupidly easy. I'm going to just plug it in. So notation though. Maximum error, which is, I'm checking for understanding, or those of you who have good memories, what's another word they might use for error? It starts with the letter R, not residual. Remainder, exactly. Yeah. They also use that word, remainder. So f of -1/2 minus, how many terms did the question say we're taking? So f5 of -1/2 less or equal to, so we're plugging in 5, is that clear? So x is -1/2 and 5 plus 1 is 6 over 5 plus 1 square is 36 times 5 factorial. Can we move on? You guys got the hang of this? Is it getting repetitive? Like, man, I got the hang of what's going on here. All right. Let's go to this problem here. Okay, so obviously yesterday, Ms. Mazu got double the extra credit for this kind of problem. So if you observe, I was a nice guy. It was the first time I introduced it. I did not assign any homework question or that. Now in the practice over the weekend, you will see questions like this. Let's see if anybody is attentive. Mazu, you're not allowed to answer this question. Okay. So copy down this. So this is the last concept. And then we'll be 98% done with the chapter. And we say, what the hell is 2%? That's just tying up loose ends here and there. But otherwise we will have. So I have been like showing Mr. Park or Ms. Mazu the AP question papers. You should be able to answer most of the AP questions on this topic right now. I'm being serious. I've virtually taught you the entire chapter. So what series should I start with? Sin x. Formula. Rios, have you memorized them? 4 terms. I need all odd powers. So what should the power be? 2n plus 1. Okay. Replace every x with x squared. Second term will become, keep looking down, third term, oh, careful. What will the last term x power become? I'm repeating every x with x squared. 4n, very good. Over 2n plus 1 factorial. Algebra, be attentive. And then last step, I multiply every term by. Okay, now I'm going to, okay, guys, look at the board. Unlike the previous problem, guys, I'm giving you a big reveal. Like a magician, I'm giving you the big reveal. Do you see, unlike the previous problem, it did not say f of x is that. Draw a skull if you're writing good notes. Oh my god. At this stage, the function we need is going to be f of x. Oh, no. That comes here. Okay, this is still, are we good? No, we're good. So, no, we do have f of x. So f of x equals -3x sine x squared. If you forget to write that, you will have trouble 2 steps down. Like, man, what is going on? I have no idea what's going on. First term. So this guy is the important thing. That labeling is super important. First term, -3x cubed plus, yes, 3x to the power of 7 over 3 factorial minus 3x to the power of over 5 factorial plus x to the power of 15 over 7 factorial plus dot dot dot. Guys, careful. Ms. Boswick, you have to be attentive. Guys, pay attention. Are we not multiplying by the negative sign? So what will that power become? Thank you, Mr. Bantam. N plus 1. You have to be attentive to what's going on. I'm multiplying every term by a negative number. That negative will become n plus 1. X to the power of 4n plus 3 over 2n plus 1 factorial. Is everybody okay so far? Is it right here? Super repetitive. Now look at B. Sorry? Oh, yeah, thank you. Times 3. Thank you. That 3 doesn't vanish. Thank you. Okay, now look at B, please. Everybody, look at B. It says, write the first 4 terms in the n term of the series of integral. Okay, I want to see if you're paying attention. What should I show on the left-hand side? Integral 0 to x. Lovely, f of x. We're integrating f of x. If you forget to write that, you will struggle with the part 2 steps down. Dx equals negative 3 x to the power of over 4. Now observe how I write the next one. Plus 3 over 3 factorial x to the power of times 8. Okay. Or you can write over 8. It's okay. Minus 3 over 5 factorial x to the power of over 12. Do the next term yourself. I'm going to focus on the last term. Plus dot dot dot. Negative 1 to the power of n plus 1. Don't forget the 3. X to the power of 4n plus 4. Thank you. Over 2n plus 1 factorial 4n plus 4. Is everybody okay so far? Okay, now look at C. So this is the third time you're getting exposed to that problem. Copy down C, please, so you know what the instructions are. Okay, anybody whose name not rhymes with Arzouk is allowed to answer the question. So the question now says, write the sum of that infinite series in B as a function. So what could we just do? Raise your hand when you figure it out. Miss Hanson. Thank you. And what was the original function after all? She's alert. Can you see? We labeled f of x to be that guy. Can we just integrate f of x? If you don't show that notation, you'll say, how can we write that as a simple function? That's an infinite series. What is going on? That's integral of 0 to x, f of x dx. F of x we labeled to be that. Can we just find the interval? Stay with me. So make a note to yourselves. We know f of x. Draw an arrow so you understand. So I'm just going to substitute. So is that series as 0 to x? F of x equals... And guys, she was just present yesterday. Come on, shame on you people. Hanson was here. She was partying in Disneyland and she just showed up yesterday. Was that negative 3x sine x squared? Dx. Yusuf? First, should we pull out the negative 3? First semester? X sine x squared dx. Introducer? U equals? Du equals? Introducer? Balance with the? So negative 3 halves. Lower limit? Now careful. Upper limit? X squared. X substitute will give me x squared. Is that just sine of u? Du. Now careful. This is integrals. What's the integral of sine u? So the negative 3 halves really becomes positive 3 halves cos of u. Lower limit? Upper limit? So upper limit, 3 halves cos square minus 3 halves. Are we good? Because cos of 0 is 1. Okay, it's not 0. Can you see a nice function? We can write that infinite thing as just that function. But you will not get it if you're not aware, hey, that was that function. Okay, last problem of the day. Okay, we're almost done.
John Parker,
Guys, again, by Monday you should all be caught up. Have any questions? Feel free to text me, call me, email me, send a carrier pigeon, whatever. Tom drums. Again, feel free. I share my cell phone number with you. Again, you'll be surprised to know all the top kids text me or call me if they have questions. Okay, stay with me. Can we do A part A very, very quickly? Stop. Is it smart to label that as f of x? That's f of x. Please be aware. What's this? They didn't put it together. They said f of x equal to x is given by. Please draw a skull and write label. That's the function they gave us. X squared over 2 plus x cubed over 3 minus x4 over 4 x over n plus 1 over n plus 1. Guys, don't get me wrong. Is that not a series you're supposed to have memorized? That's the ln1 plus x series. You're supposed to have memorized. Okay, so part A says write the first term and the n term of 0 to x f of x dx. Write the left hand side. If you don't follow basic good habits, then you're going to be lost easily. First term, second term, 2 times 3. Do not multiply. Do not multiply. Do not multiply. Minus x4 over. Oh no, what am I doing? That's x4 over. No, I'm okay. So yeah, I'm off. 3 times 4 minus minus plus here, minus here. x5 over 4 times 5 plus negative 1 to the power of n. X to the power of n plus 2 over n plus 1, n plus 2. Everybody okay there? Relax, we're almost done. We just have one more part. Now it says, use your result to find the value of. So in your notebook, just say find the value of. In your notebooks, just say find the value of. So I'm going to be clever. Smart kids, copy that down right underneath. You'll see magic happen. I'm going to copy that right underneath. 1 over 1 times 2 minus 1 over 2 times 3 plus 1 over 3 times 4 minus 1 over 4 times 5 negative 1 to the power of n. N times n plus, there's a typo there. That should be say n plus 1, n plus 2. Guys, the last one should say n plus 1, n plus 2. Okay, compare these two. It says find the value of this. Obviously, by looking at this, what should the value of x be? Just by looking at it, what's the obvious value of x? 1, let's write that down. That doesn't answer the question. Nobody speaks. Hanson answered it last time. So I need to find the value of that. If you're alive, what could we just do instead? Louder? Yeah. No, you tell me exactly where you're plugging in. Do you mean plug in there? Where are we plugging it in? Louder? Into L there? That's Ln. No. Okay, go on. Into the integral! These two match. This is exactly the situation you plug in there. Okay, this is the same as that. So the value should be same as that. So I'm going to plug into the integral. Yeah, what Hanson said last time. If you plug in there, guys, look at the board. For those who say plug in there. But that's not the same as this. Do you see that? This is not the same as that. Don't these two match up? So these two should match up then. So basically I have to do integral of 0 to x. What is f of x after all? What was f of x after all in the question? Ln. So I'm plugging in f of x to be ln, but the integral. I'm plugging into the integral function. Was it 1 plus x? Okay, bad news. This involves calculus that you've forgotten. So let me go over the calculus again. Which method should I use? Parts. They're like 1 times. So f being ln 1 plus x. F dash is 1 over 1 plus x. G dash is 1. Therefore G is x equals. Okay, equals f times g, x times ln 1 plus x. I wrote it backwards. Minus integral. Is that x over 1 plus x? Okay, nobody in the other class remembered how to do this. Who remembers how to integrate that? Yes. Oh, shut up. You're not allowed to say.
Something else.
Yeah, go on.
No, it's supposed to be 1.
What is supposed to be? Oh, yeah. He says, isn't that supposed to be 1? Isn't x equals 1? Yeah. Thank you. You can speak. Okay. Guys, who, if anybody, remembers how to integrate that? Yeah. Louder? No. Partial fractions, if you have a product, that's just a linear term. I'll give you a hint. That power is exactly the same as that power. Who remembers? Okay, nobody does. Long division. Okay. No, relax. It's a one step. It's one step. This is x. I'll rewrite it as x plus 1. Can you see 1 plus x is actually x plus 1? See if this comes back. Does it obviously go once? And that's x plus 1. When I subtract, is the remainder negative 1? So observe, I'm going to copy this down. So x ln 1 plus x minus integral 1 minus 1 over x plus 1. I hope you remember again, that's the remainder, quotient minus negative. Do you remember that concept? Can we now integrate very easily? Okay. Last thing of the day. So x ln 1 plus x, integral of 1 minus x. Careful, look at me. 2 negatives make a, and what's the integral of 1 over x plus 1? Marcus, pay attention. What's the integral of 1 over x plus 1? ln x plus 1. Lower limit, upper limit. So if I plug in 1, is that ln 2 there? Minus 1 plus ln 2 again, minus, will the first two terms collapse? Oh, do all of them collapse? Now have a look, if you plug in 0, do all of them collapse? So absolute final answer, 2 ln 2 minus 1. Whew. And we are pretty much done with most of the curriculum. Okay, that was a very odd thing to say. Oh my god. They're like,
No, dude, you see my doctor now.
oh, I know. You don't? You know his name? Oh, Doris! I never talked to you, but you're doing okay? What's your... Otherwise, I never talk to you. Oh, Miss Dawn, if you...
Feel it.